At 1:23:45 a.m. on April 26, 1986, the world changed forever. The Chernobyl nuclear power plant, located in Soviet Ukraine, became the site of the worst nuclear disaster in human history. Reactor number 4 exploded, tearing a massive hole in the roof of the building and releasing a deadly plume of radioactive material into the atmosphere. The explosion was the culmination of a series of design flaws and human errors, a stark reminder of the devastating power of nuclear energy when it escapes our control. The Chernobyl disaster did not announce itself with a bang, but with a blinding flash that lit up the night sky. A surge of power, a cascade of failures, and a reactor core exposed to the elements. The world held its breath as an invisible enemy. Radiation silently began its relentless spread. The nearby town of Pripyat, home to many of the plant's workers and their families, remained oblivious to the danger for several hours. Life went on as usual, unaware of the invisible threat that had already begun to poison the air, water, and soil around them. The world watched in horror as the Soviet Union, initially reluctant to acknowledge the scale of the disaster, was forced to evacuate Pripyat and the surrounding areas. Over 100,000 people were displaced, their lives irrevocably altered by the catastrophe. The Chernobyl disaster became a symbol of technological hubris, a stark warning about the potential consequences of human error and the devastating power of the atom. The story of Chernobyl is not just about the events of that fateful night. It's about the human cost, the scientific struggle to contain the disaster, and the lasting impact on our world and environment. It's a story of courage and sacrifice, of lies and cover-ups, and the enduring legacy of a disaster that continues to shape our understanding of nuclear power and its inherent risks. The Chernobyl disaster was not a single event but a catastrophic chain reaction of failures, both human and technological, that unfolded over time. The reactor's design, known as the RBMK-1000, was inherently flawed and prone to instability. It lacked a containment structure, a crucial safety feature common in Western reactors, which could have contained the explosion and mitigated the disaster. This design flaw, coupled with a series of operational errors and misjudgments, set the stage for disaster. On the night of the accident, operators were conducting a safety test, attempting to simulate a power outage scenario. However, a combination of design flaws and violations of safety protocols led to a dangerous and uncontrollable power surge in the reactor. The reactor's control rods, designed to slow down the nuclear reaction, were inserted too slowly, further exacerbating the already critical situation. The resulting power surge led to a rapid and uncontrollable increase in temperature and pressure within the reactor core. The fuel rods overheated and ruptured, causing a massive steam explosion that blew the reactor lid off. This catastrophic explosion exposed the reactor core, releasing a deadly cloud of radioactive material into the atmosphere. The explosion was so powerful that it scattered radioactive debris over a wide area, contaminating large parts of Ukraine, Belarus, and Russia. The Chernobyl disaster exposed the dangers of a culture of secrecy and a lack of transparency within the Soviet nuclear industry, highlighting systemic issues. The Soviet government's initial attempts to downplay the severity of the accident only made matters worse, delaying crucial evacuation efforts and exposing countless people to dangerous levels of radiation. The world watched in disbelief as the Soviet Union, a superpower that prided itself on technological prowess, struggled to contain the devastating consequences of its own mistakes.